Hello, and welcome to S2C's webinar series. In this session, we're going to take a look at S2C's prototyping solution. In this session, I'm going to give a quick introduction of who S2C is. Then we're going to talk about why is FPGA prototyping important and commonly used nowadays. Lastly, we'll take a deeper dive into S2C's Prodigy prototyping solution. S2C is a leader in providing innovative FPGA prototyping solution. It was first founded in Silicon Valley back in 2003 and has been servicing more than 500 customers worldwide over the last 18 years. It has direct offices in San Jose, Shanghai, Shenzhen, Beijing, Hsinchu, Seoul, and Tokyo, and S2C also has various sales reps worldwide. We introduced our first product in 2005, and over the years we have rolled out various platforms. The more recent products include Vertex UltraScale 440 logic systems, the Stratix 10 10N logic systems, the Prodigy S7 logic systems, which includes VU19P UltraScale Plus, and the high-density logic matrix. Here at S2C, we strive to deliver high values to our customers by keeping a close tab on the market trends and working closely with our customers to understand your pain points and what you need. We act quickly and deliver innovative solutions through both standard and customized products. Now let's take a look at some of the IC design market trends and design challenges to see why is FPGA prototyping getting more popular than ever and what it means to have a complete prototyping solution. The design challenges shown on this page is nothing new. As you're probably already aware, because of the desire to shorten time to market, project schedules are getting squeezed more and more, while designs are getting more complex than ever. And with the proliferation of SoC designs, embedded software is also growing exponentially. And lastly, complex design and projects often mean having several teams across the globe that are working remotely to collaborate. And not to mention COVID, which is making a lot of us having to work from remote locations. Designs nowadays are just getting bigger and bigger. There are designs which may only need a few million to tens of million ASIC gates, but there are also hyperscale designs which take up billions of ASIC gates and gigabytes of memories. And due to the nature of SoC and the need to run software, the verification platform for these types of complex designs need to run at megahertz range to be feasible. An IC design project most likely will take multiple teams, and different team members will have different needs. System architects want modeling capabilities for architectural exploration. Hardware developers and system integrators need solid verification platforms, while software programmers desire high-performance platforms to shorten compatibility and regression test cycles. And with team members scattered across the globe, a robust verification platform should support remote access and be easily managed to provide flexibility and reusability. While there are various verification methodologies, such as software simulation and hardware emulation, FPGA prototyping is often the preferred choice, especially for speed and performance considerations to support software developments and testing. But to meet the other challenges and requirements mentioned in earlier slides, a complete prototyping platform must be scalable, flexible, and high performance while supporting designs big and small. Such prototyping solution also needs to offer easy-to-use compilation, partitioning, and debugging capabilities. Remote access is a must, but we also need to consider multi-user and multi-project management. Lastly, these solutions should also provide reusable and upgradable options to maximize the capital investments. And now let's take a look at S2C's Prodigy prototyping solution and see how it addresses the topics that we just mentioned. In addition to providing prototyping hardware, it is also necessary for a complete prototyping solution to include accessories, peripherals, software tools, and flows to bring convenience and productivity to the table. S2C offers rich libraries of daughter cards and reference designs, high bandwidth link between PC software and DUT or device under test, runtime management and partitioning software, multi-FPGA debugging tool, and cloud management software. We will be covering these items in greater details in subsequent slides. For prototyping hardware, S2C offers several product lines addressing different needs. Logic Module offers low-profile single PCB design with capacity ranging from 3 million ASIC gates to 116 million ASIC gates. Logic System comes in a sleek all-in-one design with integrated power supply and chassis to simplify daughter card attachment and transport. Logic Matrix is an innovative high-density 8 FPGA platform designed for multi-system expansion and stacking. The compact and low-profile Logic Module product line has 6 members. We have the Kintex 7, 325, and 410 offering 3 million and 4 million ASIC gate, and the Kintex UltraScale 115 offering 7.6 million ASIC gates. And then we have the Vertex UltraScale 440 in single, dual, and quad configurations, each offering 29 million, 58 million, and 116 million ASIC gate capacity. Logic System is both a modular and an integrated design combining one or more FPGA module, a power control module, and a power supply into an all-in-one chassis. This design offers better heat dissipation, and the chassis supports flexible extension to allow more secure attachment and easier transport. And the built-in power supply supports remote power cycling capability. The Logic System product line comes in single, dual, and quad FPGA configurations. We currently support FPGAs from both Intel and Xilinx, including the industry's biggest capacity FPGA, the Stratix 10 GX10M, and Xilinx's biggest FPGA, the Vertex UltraScale Plus 19P. The most recent prototyping platform from S2C is the Logic Matrix, aimed to deliver high capacity and high performance. A single Logic Matrix hosts up to 8 FPGAs, and 8 Logic Matrix can be fitted into a standard server rack for a total of 64 FPGAs per server rack. In addition to optimizing for server rack deployment and maintenance to lower the total cost of ownership, it is also scalable by design to support multi-system expansion over multiple racks. The first member of the Logic Matrix product line is the LX1, and it is based on Xilinx Vertex UltraScale 440. The LX1 offers 3 types of connectors. Prodigy connector each carries 144 IOs or 72 LVDS pairs. PGT connector each carries 8 SerDes and 16 IOs, and each mini-SAS carries 4 SerDes and 8 IOs. Prodigy connector can be used for daughter card attachments or FPGA to FPGA connectivity over LVDS or single-ended IOs. PGT connector is often used for daughter cards requiring high-speed SerDes. Mini-SAS is optimized for granularity to enable high fan-out and long-distance FPGA to FPGA linkage. Each FPGA is connected to 8 Prodigy connectors, 1 PGT connector, and 10 mini-SAS connectors. Another crucial aspect of prototyping is transacting with real-world data. S2C Prototype Ready IP is a library of over 90 ready-to-use daughter cards, accessories, and reference designs. Prototype Ready IP covers popular applications such as ARM processor interface, embedded and multimedia, I/O expansion, general peripherals, high-speed SerDes-based peripherals, and memory module. If you can't find a matching interface, S2C can also work with you to provide a customized solution. Hardware is only half of the story when it comes to prototyping. A complete prototyping solution should also be accompanied by high productivity tools. PlayerPro is the main cockpit or dashboard to operating S2C's prototyping systems. PlayerPro consists of three parts: runtime, compile time, and debug time. Runtime provides remote system management such as FPGA download, hardware self-test, runtime monitoring, and virtual I/O control. Compile time provides partitioning and TDM pinbox insertion to fit a large design over multiple FPGAs. PlayerPro's debug time works in conjunction with multi-debug module, or MDM, which is to be covered in the next slide. And this debug time provides in-circuit debug setup, such as specifying signals to capture, setting up trigger conditions, and waveform viewing. For FPGA debugging, you may already be familiar with FPGA vendors' tools such as SignalTap or ChipScope. These tools are great, but when it comes to debugging multiple FPGAs, not only would you have to examine each FPGA's waveforms separately, you also need to plan for cross-triggering across multiple FPGAs. For system debug, S2C offers multi-debug module, or MDM, which supports concurrent debug of up to 8 FPGAs. The captured signals are aggregated and get displayed together inside PlayerPro's debug time. Another key feature of MDM is its built-in DDR4 memories to support large amounts of waveform storage without taking up precious FPGA resources on the FPGA prototyping platform. This means even if your design fits into a single FPGA, you can also leverage MDM for deep tracing. ProtoBridge is another popular productivity tool. It enables high bandwidth linkage between software running on PC and the device under test inside the prototyping platform. ProtoBridge consists of C-based API and device driver for the host PC, a PCIe Gen 3 x 8 based connection with bandwidth up to 4 GB per second, and a AXI4 master-slave IP to provide bus transactions. With ProtoBridge, designers can easily perform function calls from the PC to exercise the AXI bus inside the FPGA. In addition, designers can also employ commercial simulators to conduct electronic system level or transaction level modeling on the host PC in conjunction with FPGA prototyping for architectural exploration, software-hardware code development, and code testing. While S2C's prototyping platform and PlayerPro already offer remote capabilities, S2C's Prodigy Neuro takes resource management to the next level. Neuro enables system administrators to create users, user groups, and projects for more efficient resource allocation and management. This greatly helps with utilization rate and to achieve higher return on investments. Neuro can also provide progress monitoring and reports for designers to check on the workflow status. Tying all the pieces together, as you have seen, Prodigy FPGA prototyping is a complete prototyping solution that is scalable, flexible, and high performance. S2C offers tools to support design partitioning, software-hardware transactions, multi-FPGA debug, remote operations, and resource management, thus making FPGA prototyping a high-value and productive validation methodology. Showing on this slide is a configuration and capacity summary of S2C prototyping product lines. If you would like to get more details, please visit our website at www.s2ceda.com or contact S2C Sales. In summary, S2C carries various prototyping platforms to provide flexibility on sizing and FPGA choice. For customers looking for high performance, especially to support software development and testing, FPGA prototyping is a must. As you have seen, S2C offers a complete prototyping solution with many high productivity tools to simplify validation and help you focus on your development. You can trust S2C to bring reliability and fast time to test and results to your validation flow. We're now at the end of this webinar on FPGA prototyping and S2C's product offerings. We'll be releasing a few more webinars soon to cover debugging methodologies and hyperscale designs. Please come back and visit us soon. Thank you for watching. For more details, please visit our website at www.s2ceda.com or contact S2C Sales. Bye-bye.